Have you ever wondered how truly vast our universe is? What we consider huge, like Earth, the Sun, or even our galaxy, is actually tiny next to the real giants hidden in space. Today, we'll take you on a journey to explore some of the biggest objects ever discovered. Get ready to see galaxies, cosmic structures, and voids so enormous that thousands of Milky Ways could fit inside. Some of these objects are so large that light takes billions of years just to cross them. Even with our fastest spacecraft, it would take humanity countless generations to travel their lengths.
10th place goes to the Large Magellanic Cloud. This isn't just a dwarf satellite galaxy of our Milky Way, but a unique object for astronomical observation, located at a relatively small cosmic distance, only 163,000 light-years from us. This galaxy has a diameter of approximately 14,000 light-years. Yes, that's not much by cosmic standards, but consider this. If the cloud were to appear in the Milky Way's place, it would cover a full third of the night sky, and its light would be visible to the naked eye from anywhere on Earth. This galaxy contains billions of stars, as well as a huge amount of interstellar gas and dust. New stars are forming here at an incredibly rapid pace, undergoing processes reminiscent of the early stages of the universe's development. Many modern space missions use this nearby cloud to observe supernova explosions, study stellar evolution, and search for unique objects. The Large Magellanic Cloud is a true key to understanding the motion of small galaxies around massive ones, as well as a superb laboratory for studying gravitational interactions and the formation history of our galaxy. Due to its proximity and brightness, it has long been a favorite target for scientists and space enthusiasts worldwide. 9th on our list is the quasar TON 618, a unique object at the edge of the observable universe. This is no ordinary galaxy, but a veritable fountain of energy, generated by a massive black hole at its center. TON 618 is located over 10 billion light-years from Earth. This means that when we look at this object today, we are essentially seeing it in the distant past, before our solar system even existed. At the heart of the quasar is a supermassive black hole. It weighs approximately 66 billion suns. That's more than the mass of even the most massive galaxies individually. All the surrounding gas is drawn in at a colossal speed, heating up to millions of degrees and glowing brighter than anything else in the galaxy. Essentially, TON 618 is a beacon, observable from billions of light-years away, and one of the most important sources of information about the early universe. Such an object raises many questions. How do supermassive black holes form? Why do some quasars fade faster than others? And what can such giants tell us about past eras of the cosmos? 8th place goes to the giant elliptical galaxy IC1101, located 1 billion light-years away. This isn't just a large galaxy, it's nearly 60 times larger in diameter than the Milky Way, reaching a truly impressive 6 million light-years. IC1101 contains trillions of stars of varying ages and types. Besides these stars, its volume is filled with vast clouds of gas and dust, and astronomers speculate that it may harbor hundreds of billions of exoplanets, perhaps even with conditions suitable for unusual forms of life. This giant is surrounded by a massive dark matter halo, which is still impossible to directly observe, but its existence is confirmed by the motion of stars and gas. Scientists believe that IC1101 formed from numerous smaller galaxies that collided and slowly merged over billions of years, creating a single incredibly massive object. Here, one can observe enormous star clusters, the remnants of past collisions, and so-called spherical shells, structures formed by the gravitational interactions of mergers. Studying this majesty helps astronomers better understand the mass evolution and internal structure of large galaxies, as well as uncover the secrets of the growth and formation of cosmic objects throughout the history of the universe. Seventh place goes to one of the most mysterious and least studied structures in the universe, the Boots Void, also known as the black bubble of space. This region is approximately 330 million light-years in diameter, so large that thousands of galaxies would normally be found in this volume of normal space, yet only a few dozen have been discovered here. It is one of the emptiest and rarest zones known to astronomers. The origin of this void is still a matter of debate in the scientific community. One theory is that the Boots Void formed as a result of the merger of several smaller voids, creating a gigantic region with an unusually low density of matter. Another hypothesis suggests that fluctuations and uneven distribution of matter in the early universe, shortly after the Big Bang, manifested here. The size of the void is astonishing. If you were to stand in its center, you would barely see a single galaxy in the surrounding darkness. Only pitch blackness would surround you. Studying such empty regions is an important goal in modern cosmology. It helps us understand how the structure of the universe has changed over billions of years, and perhaps will bring us closer to unraveling the nature of dark energy and the future of the cosmos.
Sixth place on our list goes to the majestic Laniakea Supercluster. This colossal cosmic formation contains nearly 100,000 galaxies, including our own Milky Way. Laniakea stretches for a whopping 520 million light-years, uniting countless stellar worlds and planetary systems into a single, truly colossal structure. The mass of Laniakea itself is so enormous that it's difficult to even imagine. We're talking billions of trillions of solar masses. The name Laniakea means immense heaven in Hawaiian. This name was chosen for a reason. If you look at a map of the supercluster, its entire structure resembles a twisted web composed of giant threads in which galaxies are arranged like beads on a string. These unique cosmic highways determine the paths of galaxies and matter, setting the dynamics of our entire cosmic region. Studying Laniakea's structure and mass helps astronomers understand how the Milky Way moves within the supercluster, how the gravity of neighboring giants affects us, and how the universe continues to build such gigantic structures. In the foreseeable future, such superclusters could become like islands in the expanding universe. Who knows, perhaps one day humanity will find a new home here if we can learn to travel between distant galaxies. Fifth place in our ranking goes to the Shapley Supercluster, located approximately 650 million light-years away. It is one of the most massive and dense superclusters known to astronomers and is located relatively close to our Milky Way. The Shapley Supercluster comprises several large galaxy clusters linked by powerful gravitational forces, forming a single gigantic cosmic complex. The mass of this supercluster is estimated to be approximately 1 quadrillion solar masses, an amount of matter not found in any other structure neighboring our galaxy. The Shapley Supercluster's gravity is so strong that it can literally pull neighboring groups and clusters of galaxies toward it, a process that continues to this day. Some scientists even believe that in the distant future, the Shapley Supercluster may engulf entire sections of the cosmic web, including our local cluster. Recent research shows that Shapley plays a vital role in shaping the large-scale structure of the universe, a network of filaments, nodes, and voids that astronomers call the cosmic framework. It is at the junctions of these gigantic structures that the most interesting processes occur, related to the redistribution of matter, the birth of new galaxies, and even the possible evolution of superclusters themselves. Fourth place goes to a truly unique object, the Great Wall of CfA2.
Imagine an incredible structure composed of millions of galaxies, linked together and stretched out into a chain approximately 500 million light-years long. These walls aren't just elongated clusters of galaxies, they're veritable cosmic highways along which entire worlds are located, like cities on the banks of vast intergalactic rivers. They stretch for hundreds of millions of light-years, forming over centuries under the force of gravitational attraction, and gradually draw together enormous masses of matter, gas, and dust, uniting them into a single system. The Great Wall of CfA2 is clear evidence that the universe isn't chaotic, but rather forms a complex cellular structure. Between these impressive walls and filaments, there are also gigantic voids, such as the Boots void. All of this confirms the concept of the cosmic web, which underlies our modern understanding of the structure of the universe. The study of such gigantic structures is a crucial key to understanding the evolution of the cosmos. Analyzing such formations helps scientists understand how matter was distributed after the Big Bang and how the first large galaxy clusters arose, shaping the universe we observe today. Third place is rightfully occupied by the giant Hyperion Supercluster. Its discovery was a real sensation for astronomers. It is one of the most ancient and massive structures discovered in the early stages of the universe's formation. Hyperion spans approximately 500 million light-years, and its mass is estimated to be millions of billions of times that of our sun's. Scientists believe that this enormous cluster began to form just a few billion years after the Big Bang and became a kind of center of gravity for the young galaxy surrounding it. Hyperion's unique feature lies not only in its incredible size, but also in the exceptional compactness of its matter. It is concentrated in dense regions within the structure, creating a unique cosmic landscape. Studying this giant allows astronomers to draw conclusions about how the first skeletal structures formed from primordial hydrogen and helium, the filaments of which later formed galaxies and star clusters. In fact, Hyperion is a true archaeological monument of the early universe, dividing the cosmos into regions of varying density and providing us with a valuable window into the childhood of the entire galactic family. Thanks to such objects, we can peer into the past and understand the stages of the universe's development in its earliest stages. Second place goes to a massive cosmic structure with a name worthy of an ancient myth, the Hercules Wall, Corona Borealis. This gigantic wall of thousands upon thousands of galaxies stretches for more than 10 billion light-years. It's so enormous that it constitutes a significant portion of the entire visible universe. Amazingly, this phenomenon was discovered only recently, and according to the latest data, it is the largest known galaxy cluster. Its scale is truly staggering. For light to completely cross it, it would take much longer than the existence of our planet Earth. Scientists continue to debate whether the appearance of such gigantic structures can be explained by modern cosmological laws, as the existence of an object of such size doesn't fit into conventional models of the formation of the universe and raises new questions about its evolution. Perhaps studying such walls will reveal unknown mechanisms of cosmic evolution and bring us closer to unraveling the very nature of dark matter, as only colossal reserves of invisible matter could have formed such massive structures. Such objects become the key to understanding the structure and history of the entire universe. And finally, the absolute champion in size is the visible universe. It encompasses everything humanity can discern and see with modern telescopes, a vast sphere approximately 93 billion light-years in diameter. This colossal volume contains hundreds of billions of galaxies, and each of them contains billions, if not trillions, of star systems. Every time new, more advanced telescopes are developed, our horizons expand even further, and we discover ever more astonishing and impressively large objects. The visible universe is not just an abstract space on our maps, but a central focus for questions about fundamental physics, the age, future, and geometry of the entire universe. Its boundary is not a wall at all, but a special surface behind which lies light so ancient and distant that it simply hasn't had time to reach us in the entire history of the cosmos. Every new space mission and every scientific breakthrough is an attempt to uncover a new part of this giant, to make the visible universe a little larger. Perhaps in the future, its boundaries will continue to expand, opening up ever new horizons for science.